Well, hey everybody, we are getting ready to start our last section in Chapter 5, translating graphs or translating functions. A good thing to remember when we start off with here is our parent functions. Now, we have not really learned how to use all of these types of functions, but we can identify them and realize that each one has a unique shape to it. Like linear. Linear forms a line in its most simplest form. This is what it looks like, y equals x. Intercept of 0, a slope of 1. Here's an absolute value function, y equals the absolute value of x. It is centered at the origin and a slope of 1 on each side. This right here, look, this is a radical function. Starts at 0 and whoosh goes that way. And then we have quadratics. It's a U-shaped graph that is centered at the origin. Anytime we add or subtract numbers to this, whether it's on an inside or the outside of the function, it causes them to move. We'll have that shape, this parent function shape here, can either move up, down, left, or right. This can move up, down, left, or right. No change going on whatsoever to the slopes of the lines or the vertical stretches or compressions. It is just going to be upwards, downwards, left or right movements. And that's what we have to learn how to identify and be able to apply today. Let's keep going. Right. In general, graphs can make 3 types of moves for us. Okay. They can flip. So notice this. If there is a negative out front, it actually causes the whole thing to flip upside down from wherever it is. Negative outside makes it flip over. Okay. So in this one here, if we wanted to sketch this particular graph, we want to, here's the graph of f of x. F of negative x would be literally, it's like a mirror image, the best you can, upside down. There you go. The negative causes it to flip. The second way it can move up or down. Up is a positive movement. Down is a negative movement. And this happens outside of the function. So remember, again, here, our parent function was here. Right? This is the square root of x plus 3. The plus 3 is outside. It means from its original spot, it's going up 3 units. This one here, it went down 2 units. That's why it's minus 2 outside, the plus 3 outside. Okay. Now we're going to take these. They give us 2 different examples on the same. We could have a left or a right style movement. And again, I'm showing you in all the different shapes what happens. Notice in this, here is the function f of x. So this in here, here's your function f of x. This is f of negative 3. So in this case, we have to be careful because this is how it moves. If they subtract on the inside, it moves to the right. If they add on the inside, it goes to the left. So this is the parent function. Plus 1 on the inside moves it to the left one. This function here, minus 3 on the inside, moves it to the right 3. Again, the plus 1 was a left shift. The minus 3 is a right shift. And as you identify these types in your homework, you should be circling them and identify the movement it's going to go. That way, we're not just doing it. We're not aimlessly doing it. We're trying to learn it so it stays in our heads. 3 different types of movement. It can flip. They can go up or down. They can move left or right. And it's all about these movements here. And sometimes 2 movements can happen at one time. So look at this one here. Originally, the parent function was here-ish. Actually, that's not very good. Bad drawing on my part, right? See if I can draw a better original graph. It's not easy when you're drawing with a mouse. Origin right there and up. It's a little better. Okay, that's the parent function. What happened to it? First thing, it flipped negative. And then it did what? It moved 2 units left. So x minus 2. So that's a plus. So this movement is when you, to the left is when you add on the inside. So they went 2 units to the left. That's addition. And then what happened? It went down 1 unit. So you subtract 1 from the outside. The parent function here flipped. There's your negative. Move to the left. That's a plus 2. And it's all squared because this is a quadratic. And then it went down 1, minus 1. Can we identify if this is your original graph, what's happening from 1 to 2? What happened from 1 to 2? Right? You see it's flipping and it's moving. So all of these are based at the origin, right? And this would be your parent function. Parent function. This is an absolute. This is the absolute value of x, y equals. So it moved, what, 1 unit to the left, so that's a positive. It moved 2 units up. So again, if you wanted to write the equation for number 2, absolute value of left would be x plus 1. So you moved 1 unit. And then it moved up 2. Look at this one here, right? You're starting off again, parent function. This one moved 2 units to the right, which is a negative movement. And it did move up or down. So there you go. Stood here. Oh, what about this? Hang on. I just noticed something with 2. It also did what? It flipped over. So it's negative absolute value of x plus 1 plus 2. Go to look at some of these other ones. What's happening for this one? Here's your parent function. It went down 1, which is a negative movement, and it went to the right 1, which is a negative movement. So this is radical x minus 1, and outside minus 1. Look at this one, y equals. It went to the left 2, that's a positive movement, and it didn't go up or down. There you go. Not too bad. Then we keep looking at these guys, and we want to be able to say, hey, what is going on? Can we keep doing these? Yes, we can. Absolute values, how are they moving from 1 to 2? What is the units that it's moving? So from here to here, if you want to look at this one, how did you go from 1 to 2? Well, it went what? 2 units to the left and 2 units down. How did this one move from here to here? It went down 1, 2, 3 units. And over, so down 3, over 2. From 1 to 2, again, what did we do? It went left 3, I'm sorry, left 2, down 2. So sometimes they just want us to identify where is it going, not just write the equation, but how or what were the units of movement from one to the next. And again, to make sure that as we're starting to write these, if you think about this, I always like I like doing it with an absolute value symbol. I do a plus or minus a 1. So plus means it's going to move to the left. Minus means it moves to the right. Plus means it goes up. Minus means it goes down. This is just a quick little legend you can draw to remember. And a negative out front means flip it. All right, that's it, guys, on this lesson. It is not really bad. We are finishing up the end of this chapter. We have to understand the movements that they are going to give us in these and be careful that when we execute them, we know what it's doing. This, again, I would say if this is you just got to be careful. They could also do these function notations, like here is the function f of x. Describe the movements that happen to this function from here to here. All right, so this would be f of x minus 2 minus 3, because it went down 3 units and it went to the right 2 units. We wanted to write this in a function notation again. You say, here's the function f of x from 1 to 2. What happened to it? It went where? To the left. Yeah, that's right, left. So it transforms to this f of x plus 2 plus 2. And the way to write it in function notation, or actually to write out each equation. Got to be careful, just got to do your work. That's it, guys. Delta Math is open for you. Get your work done, and we will have fun doing it, right? Have a great one today.